Geometry 1, Chapter 4, Topic 5. You should be able to identify and count lines of reflection, symmetry. So an example, identify if the following shapes have reflective symmetry, and if so, draw the lines of reflection. Now reflective symmetry is a line where essentially if you were to fold the shape in half along that line, the two pieces would match up exactly. So we look at this first piece, this first picture, it's kind of a cloud. And we look, is there any part here that looks different than the rest? So I would focus right on this part right here. It kind of loops in a little bit further than the other loops. If we were to be able to fold the shape in half, we would need that little extra part to have, say, like a partner to reflect onto. And if we look around the shape, there are no other pieces that go that far in. So there's no symmetry here. There's no part of the picture for this extra piece right here to match up to. So we look at the second shape. Here we have 6 sides. We have a hexagon. And we look. For example, right here, there's kind of a corner missing. Well, if we reflect it, if it has reflective symmetry, that corner missing would need to reflect to a part where the corner is missing. And the nice thing is that right here, there's a corner missing. So let's check. If we were to fold the shape in half right along that line, would the left and the right side match up? Would they look the same? And in fact, they would. See the two pieces, this side and this side, look exactly the same. 3 sides each. We have a long, a short, a long, a long, a short, long. They would match and basically fold onto itself if we were to fold the paper in half. But are there any other distinguishing features or any other ways that perhaps we could fold this? Now if we folded vertically, we would have a little bit of an issue because this corner that's missing, if we folded it vertically, would fold over onto the corner that's not missing. So we can't fold it vertically. Similarly, we can't fold it horizontally because the corner that's missing would fold up to the corner that's there. But what about if we folded the corner that's there to the corner that's at the bottom? Well, there is one more line of symmetry, and it's right like this. That we could actually fold our paper like this. And this corner would fold over to the bottom right, and the two pieces, or the two corners that have pieces missing, would essentially fold onto themselves, just a little bit on the left and a little bit on the right. So, 2 lines of symmetry. And we move on to the third picture. Here, it's a square inside a square. Now the square has quite a bit of symmetry because all of the sides are equal in length. So here you can draw your line vertical through the center or horizontal because all 4 sides are the same shape. However, you can also fold your paper along the diagonal if it's a perfect square. They use that quite a bit in things like origami, paper art, and you can fold it the other diagonal because all 4 sides are the same length. The square on the inside doesn't change anything when it comes to your symmetry because they are oriented the same way. So now we count the lines. That's 1, 2, 3, 4 lines of symmetry. Now it's not expected that you pull out a ruler and you measure carefully and you use straight lines as you draw those lines of symmetry. However, it is expected that they are approximately in the correct place. If you draw your line of symmetry, say over here, off to the side, that would not be sufficient. It needs to be more or less in the middle, vertically, horizontally, corner to corner, enough so that we can tell exactly where they are that you're trying to draw.